Hello students, this is Nitya Priya. Even today we are going to see the concept, the final concept in Unit 2, which is segmentation and demand-based memory management. Right, and these are the contents of the concept. First we see about paging and segmentation. Then we see paging and segmentation separately. First we see paging, then the paging process, then segmentation process. Then at last, how can we combine segmentation and paging and just we come out with the advantages of the particular technique. Okay, right. So this slide speaks about paging and segmentation. We already discussed what paging is and also what segmentation is. Okay, so paging is dividing the disk where the jobs are stored into equal pages. Okay, so that is called pages. Whenever we talk about paging, the division will be of equal size. Okay, so these pages will be accommodated in the physical memory or the main memory of a computer. So that memory partition in the main memory will be called as page frames. Okay, so division of jobs in the secondary memory or disk is known as page, and the division of main memory is known as page frame. So what we do is we accommodate the pages onto the page frames on the main memory. So this is called paging. Next we come to segmentation. Segmentation is the same way we have jobs on disks, but we don't divide the jobs as they are into equal parts like paging. In segmentation, we divide the jobs as per the processes. Okay, so one job will be having many processes. Okay, so each and every process will be divided as a segment. So what happens? Each and every segment will be of different sizes. Okay, like paging, they will not be of equal size. They will be of different sizes. Okay, right. So these segments will be accommodated on the main memory or the computer's memory, hard disk. Okay, right. So in paging, we have pages and page frames, where both are having the equal sizes. Okay, every page is of equal size and every page frame is of equal size, and the page size is equal to the page frame size. For example, if a page is of 1000 KB, the page frame will also be of 1000 KB. But in segmentation, the segment will be accommodated in the main memory partitions. Okay, there the segments will be not of equal sizes. Okay, because it is divided according to the process, it will be of varying sizes. So this is what all about paging and segmentation. Right. So we see paging in detail here. Paging, I said, paging specifies the partition of pages or partition of jobs into pages. Okay, so every page is of equal size, that we know, right? Okay, so these are the technical terms of paging. We see page is a fixed length contiguous block of virtual memory. Okay, right. Then frames, I said frames will be on main memory or RAM. Then physical memory is RAM. RAM only is called as physical memory. Then virtual memory is a portion of the disk. Whenever paging is done, virtual memory is offered. Virtual memory is an illusionary memory which is not actually available in the hard disk, but we show that there is some extra space to the job, so that the job will be immediately accommodated on the hard disk. But physically the memory is not there, it is an illusion. So that is why it is called as virtual memory. So this is the concept of paging. Okay, right. Then we see virtual address. What is virtual address? An address in the virtual memory is called as virtual address. Okay, so virtual memory is illusionary memory, as I said. Then physical address. Physical address is what? It is the address in the physical memory, the main memory of the computer or the RAM of the computer. Right, and that's all about paging. Then the paging process. Okay, so I already said when I started the concept itself, I told what paging is. Okay, so that's it. Page table, right, we use an additional hardware called page table or page map table. Okay, we usually say it as PMT, page map table. Okay, so this page map table just connects the pages with their corresponding page frames. So this is called page map table. Okay, right. So when we connect pages and page map table, usually what happens, we will check PMT, page map table, whenever we transfer pages into page frames. So this will take time, right? So this is called as lookups. Lookups means for transferring every page onto the corresponding page frames, we'll have a look at the page map table. So for every view of the page map table takes some time. Okay, so this slows down the process of paging. Okay, and to enhance this, we have another hardware called look-aside buffer. Okay, translation look-aside buffer, which is shortly known as TLB. This TLB just caches the mapping of pages and page frames. So the buffering, so this mapping details will be buffered on TLB, translation look-aside buffer. So this will enhance the speed of paging. Okay, so when we have this translation look-aside buffer, we need not look at the PMT every time when we pass pages onto page frames. So this will enhance the speed. Still, the speed will be slow in paging concept. Okay. So the next one is segmentation. Okay. So what is about segmentation? Segmentation is actually, it is I said what segmentation is. Okay. I already told what segmentation is. Segmentation is dividing up of processes into unequal sizes depending upon the process. Division of jobs into unequal sizes depending upon the processes inside it. Okay, right. So that is called segmentation. Like PMT in paging, we have segment table in segmentation. The same thing it does here. It connects the segments with the corresponding partitions in the physical memory. So this is called segmentation, segment table. Okay, right. So in segmentation process, each segment stores the corresponding process, primary function, data structures and utilities. See, one thing you have to keep in your mind, the processes are something that is there inside segments. Okay, one segment will be having more than one processes. That's it. You have to understand this point. Okay, so each segment stores many processes and each segment stores the corresponding process, primary function, data structures and utilities inside it. Okay, so that's it in segmentation. And the CPU keeps segment map table, as I said, to map every segment to its corresponding memory block. Right. So although segmentation is considered to be higher speed compared to paging, the external fragmentation is there in segmentation. Right. So what is external fragmentation? External fragmentation is actually when a segment is divided, the segment will be dedicated for a process. Okay. So when an unused memory is there inside a segment, a portion of memory is there inside a segment, and another portion is there outside the segment, the free spaces are scattered, right? So for example, inside one segment there are 10 KB free, and outside the segment there is another 20 KB free. But when there a process comes which needs 30 KB, we cannot accommodate the process, because even though we have the 30 KB available in memory, they are scattered. Inside it is 10 KB, outside the segment is 20 KB. So this is called external fragmentation. Okay, so external fragmentation is the biggest problem in segmentation. Okay, segmented memory management. This external fragmentation worsens and slows down the segmentation process. Right. So we at last combine both. We combine paging and segment. Okay. So paging and segmenting are both combined and we come out with a new technique called segmented paging, right? So what we are doing here is we just divide the page into we just divide the memory into variable segments. Okay, we know segments will be of varying size. Okay, so variable sized segments, and each and every segment will be having different pages inside it. Okay, so I repeat, the main memory is divided into variable sized segments, and each and every segment will be having many number of pages inside it. So this is called segmented paging. As usual, to help out the pages, we have page map table. To help out the segments, we have segment table. Okay, right. So when we couple both segmentation and paging, the advantages would be less memory usage. Okay, because segmentation is an advancement of paging, right? So there the memory space is less used. When they are coupled, the memory usage is still lessened. Okay, then it offer more flexibility on page sizes. Okay, right. So that's it. So the page sizes are of equal sizes. So that is the problem in paging. So when we combine paging with segmentation, it is more flexible. Okay, page size is more flexible. Then simplified memory allocation is done. Then additional level of security will be offered, right? And these are the advantages of segmented paging. And more than that, this process, when segmentation is combined with paging, it would not cause external fragmentation, because in paging we always overcome fragmentation. So in segmentation, the problem is external fragmentation. So when segmentation is combined with paging, this external fragmentation problem is overcome. And I hope you understood. And herewith our unit 2 ends. Thanks for watching.